Seal Aftermarket Products engineers and manufactures Toledo Transkit with the rebuilder in mind, including everything you need to get the job done right. Toledo Transkit is the #1 choice of installers because of all the intensive research and development that goes into each component in every kit. Like re-engineered valve body gaskets, preventing EPC damage by eliminating the shredding you get from original equipment, plus all of the extra essentials that are included, like spring and screen filters that should be changed at overhaul. Toledo Transkit even includes loose valve body gaskets that fit all 19 bonded separator plates. At Seal Aftermarket Products, we don't just make kits, we make kits better. Ask for Toledo Transkit by name.
The broadcast is now starting. All attendees are in listen-only mode.
Well, hello everyone, and welcome to another ATRA webinar. My name is Mike Souza. Today we'll be presenting the 722.6 transmission, also referred to as the NAG-1. This transmission obviously can be found in Chrysler products like Dodge, Jeep vehicles, and some Chrysler cars, and obviously it's found in most Mercedes. First, I'd like to thank Seal Aftermarket Products for sponsoring the webinar that makes it free and available to everyone, members and non-members of ATRA. Any questions or comments, please send your emails to webinars@atra.com. If you have any questions that you want to ask during the webinar, please feel free to go ahead and text them to me, and I'll do my best to be able to answer any questions that you text in. A lot of times guys ask me, they say, gee, we went from the 722.6 and we jumped right up to 722.9. Whatever happened to the other two numbers in between? Basically, the 7226 is still a 5-speed, so obviously the last digit doesn't refer to the forward speeds. Same thing with the 722.9, that's a 7-speed. Well, there is a 7227 and a 722.8. These vehicles that are equipped with this transmission are not found usually in the U.S. Although I've seen some of them around the Washington, D.C. area and some in Canada. A lot of the guys overseas that are based in Germany will sometimes purchase one of these vehicles and bring it back to the States. The 7227 is basically a front-wheel drive 5-speed similar to a Honda. The 7228 is a CVT transmission. Now, both these transmissions can be found in A and B class Mercedes vehicles, like I said before, mostly found in Europe. The CVT, from what I understand, because I do a lot of calls over in Europe on this transmission, seems to be real high and having failure problems. So luckily we're not seeing too many of them here. Although the 7226 came out after the 7225, it's still a 5-speed. They had a lot of problems with the 5th gear section of the 7225s, as well as you guys have probably run into in the past working on those. So this unit basically replaced that. So now that's out of the way, let's take a look at the 722.6. This is the North American Mercedes VIN ID, and there'll be several charts that we're going to talk about. One chart will show the type, body style will be in chart 2. The year model will be found in chart 3, and also the manufacturing plant is found in chart 4. These are the 4 charts that I was talking about. As you can see, that the identification numbers on the VIN will help you determine where it was built in the model year and so forth. Now, vehicle identification is important. This tag that we're looking at here on the side of the transmission, this is a good time to take out either your cell phone camera, or some guys like to keep an inexpensive camera right there laying on the bench to take pictures of valve body check ball locations and things like that when they've never seen that particular unit before. The reason that I say that we want to take this information down is because it's important that we have the correct transmission for the vehicle we're working on. The planetary tooth count, the pinion gear, the actual ring gear and sun gear tooth counts are different on many models. And if it doesn't match the vehicle, obviously we could be chasing ratio codes only because the wrong ratio was installed. So this is a good time to take a picture of those IDs if you have it on your bench. And what you need to do is save your own chart. Start putting a chart together as to what year, make, model, engine size that it came from, and count the two counts on the planetary system so we know what goes to that vehicle. There's no list of, that I know from the manufacturer's point, a list of any of these ratios for what vehicles they go to. So it's good to record your own and have your own database on it. Now, looking at the transmission barcode, right after the 5 letters that we see, we notice we have 3 digits. That's going to be the actual Julian date when the vehicle was actually built. As you can see here on the vehicle ID calendar, we had a 344, and that's for December. And as you can see, if you look across to this side of the chart, this is the day that it was built. So we know that that ID number is for the 10th of December. If anyone remembered the ID that we saw on the first picture of the transmission, it was actually a 262. So we know that that was built in September, and the day it was built was on the 19th. So the information there is pretty handy to have. Model designation, Mercedes obviously refers to it as a 722.6, and then Chrysler and Sprinter may refer to it as something else. The engineering design, the numbers that we refer to, as you can see, the 6 doesn't refer to the forward speed. That's a sales designation. When we see the sales designation, like you'll find if you're looking it up on Mitchell's or All Data, you may see it called the W5A 580, depending obviously on the torque capacity of the transmission. Now the number 5 here definitely refers to the amount of forward gears that the transmission has. The 580 is the maximum input torque. These are the applications that you'll find in most Chrysler and Jeep products. As you can see here, we have the Grand Cherokee, which shows BUX, which really means built up for export. Now, at first, when these models came out, we didn't see diesel engines in a Jeep here in the U.S. They were mostly found over in Europe. But now we're starting to see more and more Jeeps with diesel engines found in the U.S. So you have that information on that chart there. And this is the Mercedes application chart. Now these numbers that we have after the 6 are kind of important. Obviously this model is going to, a 646 is going to be for that particular vehicle that it belongs to. So the valve body has to match the transmission, which has to match the differential, tire size, and engine size of the vehicle. So any mismatches here can have you chasing shift faults or codes, and it's only because we have the wrong assemblies mismatched together. This is the component application chart. We have 3 brake clutches, we have 3 driving clutches, and this unit has 2 sprags. You can see we have an F1 sprag that's held in first. The F2 sprag is held in second, first and second. Now the other thing odd about the 7226 is you'll notice here we have 2 different reverse ratios. Obviously in regular reverse that we're going to have the B1 clutch and the F1 sprag holding, and then if you're in winter mode or sport mode, you'll have a second ratio for reverse, and as you can see the K1 clutch is holding for that one. Now let's talk a little bit about the solenoids. These can be confusing because Mercedes uses 6 solenoids on the valve body. There's 3 shift solenoids, a converter clutch solenoid, a pressure control solenoid, and a shift pressure control solenoid. Now the terms that Mercedes uses for these solenoids may not be related to the function of that solenoid. Now the 3 shift solenoids, the first one is a 1, 2, 4, 5 shift solenoid, and then you have a 2, 3 shift and a 3, 4 shift solenoid. Now those are kind of obvious. They're obviously going to be for those particular shifts. However, the lockup solenoid is referred to as a PWM solenoid. Most of the times when we hear that a PWM solenoid, we automatically think of line pressure, but that solenoid is actually for lockup. It is a PWM solenoid, so it's going to control the apply and the amount of slip rate on the converter. Now the last solenoid is the pressure control solenoid. That one is referred to as the modulating pressure regulator solenoid. The shift pressure control solenoids are somewhat unique, and we're going to cover that function a little bit later. Now, the modulating pressure solenoid controls line pressure just like any other computer-controlled transmission. It's going to raise pressure on the spring side of the pressure regulator valve, so obviously it takes more line pressure to stroke the valve, and then we build line rise that way. The PWM solenoid, pretty standard, straightforward lockup solenoid. It's going to control the converter clutch operation. Now, where the Mercedes is radically different is obviously in the way the shift solenoids work. Now, because each shift solenoid releases one clutch while applying the timing of the next clutch coming on. This is to prevent flares or bind up during the shift transition. Each shift solenoid has its own bank of 4 valves. So each shift solenoid is going to have a command valve, a holding pressure valve, a shift pressure, and a pressure overlap valve. And we're going to show you that here in just a moment. So we have a total of 12 valves controlling all the shifts on this transmission. The basic operations of the 4 valves works the same way for each shift. So to initiate a shift, the computer is going to turn on, for example, the 1-2 shift solenoid. Now, as the computer turns on the 1-2 shift 4-5 solenoid, it strokes the command valve and starts to initiate the actual shift transaction. The other 3 control valves are going to control the rate of the B1 brake which is being applied and the K1 clutch, the B1 brake being released and the K1 clutch being applied. Once the shift is complete, the computer will turn off the 1-2 4-5 shift solenoid. That's normal, and that's where it gets a little bit confusing. If you're monitoring the solenoid operation the first time you've seen this, it's kind of odd because you'll see the solenoid come on, the shift happens, then all of a sudden the solenoid goes off. So we have no solenoids on once the shift is complete. The same thing is going to happen when we go from a 2-1 shift. On the downshift, you're going to see the computer turn the same solenoid on again, the 1-2 4-5 shift solenoid. Once the transition is complete, the computer will then turn the solenoid back off once we're back in first gear. Now the shift from second to third, same thing. You're going to see the 2-3 shift solenoid come on. Once the shift is complete, the solenoid goes off again, then all 3 shift solenoids are off while we're in third. Again, 3-2 downshift, same thing. You'll see the solenoid come back on, we get back into second gear, all the solenoids are turned off again. Now, during each one of the shifts, the shift pressure control solenoid is going to control the amount of rate of the release clutch, and the modulator pressure solenoid is also going to be controlling line pressure at the same time. So these 2 solenoids work together during the overlap of each shift. So it's kind of important that we make sure that these solenoids are clean, there's no debris in them, they're not hanging up, because that can cause a lot of shift concerns. On the next page of your handout, you'll see the identification of all the solenoids. As you can see here, these 2 solenoids, this is your line pressure and shift feel solenoid, the shift pressure regulator. Now, we can obviously swap these 2 solenoids back and forth if we needed to, just to test to see if that's causing our problem. Now, the other 3 solenoids that you're going to see, these 3 right here, they all have the same flat tops to them. Now, we can swap any one of these 3 around also to check for or to diagnose any kind of a shift complaint. Now, this one over here, this solenoid is for lockup. That's the only one that's like that, so you can't switch that one with any of the others. There's your solenoid apply chart, and like I said before, we're in first gear, none of the solenoids are on. So all 3 shift solenoids are actually off. Now we'll see that the modulating pressure solenoid is modulating and the shift pressure control solenoid is on. Now as we make the 1-2 shift, we're going to modulate the 1-2 4-5 shift solenoid, and then we're going to modulate the shift pressure control. Once the shift is complete, no solenoids are on, no shift solenoids that is. The modulating pressure solenoid is still going to be modulating, and then you'll actually see the shift pressure go back to on. Again, coming back down from second to first, you see the same reaction from the same solenoids as we did during the upshifts. And you can see that through the chart that all the solenoids basically work the same way. These are the 4 banks that I was talking about. This is the 4-valve bank that we have for the 1, 2, 4, 5 solenoid. On the right here, this is 3 of the 4 for the 2, 3 shift solenoid. There's the legend on the next page. This is the last of the 4 for the 2, 3 bank, and there's the 4 for the 3, 4 shift solenoid. You notice the only thing that changes on the name is what the solenoid is, the actual solenoids are controlling that valve. So they're all named the same, they all work the same way for each solenoid. Check valve locations are located on the next page. You have 4 plastic check balls. These are shuttle balls. The 8 steel balls that you'll find in the valve body, those are for clutch exhaust. They're actually used to regulate clutch exhaust. One of the things I want to mention here is on this transmission, do not use a grease that's too thick. If it takes a thicker grease or even white lithium lube, it takes more heat to actually melt that grease. So if the check ball doesn't stay free inside especially the ones inside the bathtubs, we could have an issue with shift feel. So it's always good to use something like Vaseline or Transgel that's designed to melt quickly with heat. This is the filters and the pressure feed check valve locations. Notice that there's a little spring type lever on the bottom of the screen. We want to make sure that that's not broken. Obviously, if the screen falls below the casting here, it's not going to be up against the plate, and it's really not going to be doing its job. The same thing, especially with this pressure feed check valve that you see in the bottom right. The small side of the check valve has to have pressure against the plate. Again, when we put the thicker piece down in first, we want to make sure that this top part just a little bit above the casting. This is a question that I run into all the time with guys, and I just want to kind of make this a little clearer for everyone. How do the speed sensors work? We have 2 speed sensors, as you can see here, right on the conductor plate. The first thing I want to mention is these are input speed sensors. This is not an input and output. Now the N3 is the one towards the front of the trans, the N2 is towards the middle of the trans. They're both Hall effect sensors. Both of them have the same resistance of 4.5 ohms. Now the weird part is a lot of guys will be diagnosing this, and on data stream you'll see that the speed sensors aren't doing anything in first gear. Hold on just a second, we have a question. Is there a way to print out this information? There should be a PDF that you could download of all this information. So this actual webinar is in the PDF that you should have been able to download right onto your computer. Hope that answers your question. Okay, so anyways, guys have changed the conductor plate because obviously these speed sensors are part of the conductor plate. They may have a code for the N3 or N2 speed sensor, and when they change the plate and they monitor it, they'll call me on the tech line and say, hey, the speed sensor is not working in first, and then it's working in second, third, and fourth, and drops out again in fifth. Well, that's normal. Both the N2 and the N3 are going to read the same in both second, third, and fourth. This is the way the computer can tell if there's any slip issues. The N3 is not going to read in first or fifth gear. It will read reverse in the sport mode, because as you can see here in the chart, the K1 clutch is not on in first, fifth, or normal reverse. And that's what the N3 is reading, same as the N2. It's reading the K1 clutch apply. So neither one of them are going to read in reverse. And well, the N2 won't read in reverse, but the N3 will if you're in the sport mode. Now, both sensors being Hall effect, they're going to create a 4 to 8 volt pulse square wave. Okay, yes, the PDF should have been emailed to you in the invitation. So you may want to check your email to see if your PDF file is there. Okay. Now, the N3 is reading that K1 clutch drum, which has the F1 sprag and the B1 clutch hub all assembled into one. Now that's being held in first gear because the sprag is holding in first gear, as you can see here. So the sensor is looking at this exciter wheel. One of the things I'd like to mention is you can see how it's like pressed into this this drum. So you want to make sure that's not loose. That can give you a false speed sensor signal. So you could be changing the speed sensor only to find that you have a problem here with the exciter wheel being loose on the drum. Now the N2 actually reads the front carrier assembly, so you can see this is not an output speed. They're both input speeds. Again, too, we want to make sure that this exciter wheel is not loose. So we want to check this on the carrier and make sure that it's good and tight. Torque converter operation is nothing really unique here. It's usually activated in third, fourth, or fifth. There's always going to be a slip to this converter. It's never going to go to a 0 RPM slip. That's normal. Now the amount of slip depends obviously on road conditions, where you have the shifter shifted to whatever gear you're in. Temperature is going to be a factor also. One of the things I do want to mention is don't be concerned if you see that the actual housing of the converter has a blue or a bluish tint to it. That's normal, because the way the factory furnace brazes the fins on these converters, it actually makes the color of the steel look like it's blue. I know we're used to seeing something that if it's metal and it turns blue, that it's been overheated, but that's actually the normal look of the converter. So don't be fooled by that. Obviously, if we have a transmission with extremely burnt fluid, we're going to want to change the converter anyways in case the clutches inside are burnt. One thing that's important is we're going to look at another ID tag, and as you can see here, this is a good time to get your camera back out and take a picture of this ID label, because it has to match the transmission, which matches the vehicle because of differential ratios, tire size, and engine size. So we want to make sure that we get this information recorded and keep it in a database. Some of the converters on these vehicles have a spring damper inside and some don't. So mismatching converters can actually make a lot of shift complaints, especially lockup complaints or shutters. So we want to make sure we're using the right stuff. There's a way you can actually air check the torque converter if you feel that the clutch is not holding. Basically take the K2 drum, as you can see here, install it down inside the converter, and we can apply some shop air to that and see if the converter clutch is holding. You want to be careful here. Obviously, if there's some oil in the converter, we don't want to spray it all over ourselves and everybody around us. There's the case location for applying air to check the clutch packs here. One of the things I probably mention at every one of my seminars or webinars, you'll probably always hear me say that you should put some type of a regulator on your blowgun and actually do your air checks with 30 psi. When you're taking apart the B2, B3 clutch housing, the B3 piston, one of the things that I would do here is I'd make an ID mark, whether it's a scratch or a couple of dots like this. We want to align this correctly when it goes back together, because as you can see, this is splined into the case. So if this is off a little bit from the actual housing, when we slide this back down inside, we're not going to be able to align the bolt holes up correctly for the bolts to hold this in place. So it's a good idea to, before we take the piston off, to go ahead and make an ID mark there. Let's talk a little bit about shift complaints. Shifts to fourth gear, drops back to third, kind of a bindy feeling on the 3/4 shift. Obviously, it will go to failsafe eventually. One of the common areas that we find problems with is right here in the springs on the 1, 2, 4, 5 command valve. What's really nice about having this bank of 4 valves for each shift, we know that if we're having a problem on the 1, 2, or the 4, 5 shift, I'm going to go right to these 4 valves. These are the only 4 valves I'm going to check. So I would definitely take these valves out, make sure the bores are okay, there's no scratches and things like that on the valve. We find a lot of these springs being collapsed or actually broken. So if I'm in here with a scribe or a small screwdriver and I feel there's no tension on the valve, obviously I got a problem with the spring. But these should be checked anyways. Let's talk a little bit about our 2 sprags. A lot of times we've been misdiagnosing shift complaints not thinking that a sprag could actually cause it. One common problem that we found when the 545 RFE first came out, the low reverse clutch and the underdrive clutch are on for first gear. When they dump the low reverse clutch at about 5 or 6 miles an hour, the sprag has to hold before the 2C clutch applies. So obviously if the sprag is bad, we would get a 1-2 flare. And I've had several guys when that unit first came out chasing their tail looking for a hydraulic slip or a valve body or solenoid problem, only to find out that it was the sprag actually causing the flare. The same thing can happen with this transmission. A lot of the complaints that I get is a slip, bang, or chatter on takeoff. The most common of all the complaints is a 2-1 downshift clump. And once in a while I'll also get a 1-2 flare. So you can see that the sprag here has to hold during the transition of the 1-2 shift. The B1 clutch is releasing as the K1 clutch is being applied during that shift. So obviously if that sprag's not holding, there's my 1-2 flare. One of the other points I want to mention is before 2004, if you're working on one of these units, the sprag has been updated from 16 elements to 20 elements. You should have the part number in the handout material also. Another thing we want to do is take a real good look at the status report right here, because that's the inner race for that sprag. So if you see any damage or gouging in here, we're going to have to replace that also. Now the F2 sprag can actually cause a 2-3 flare complaint. Same thing, that sprag is holding in first and second. When it goes to make the 2-3 shift, the K3 clutch is being released, the K2 clutch is coming on. Obviously if the sprag's not holding, there's where I'd get a complaint of a 2-3 flare. That is the most common complaint for that sprag failing. One of the things when you take the sprag apart, if you're cleaning it up, these actual elements may fall out of the sprag assembly. It's not a big deal, just got to remember that there's a small foot on one side and a larger foot on the other. So you want to make sure that the larger foot faces towards the outer edge of the sprag. This is one of those after rebuilds you got bit because you didn't catch this problem when the kit came in to you. There's two different clutches for the K2 clutch. And obviously you can see once the clutches are assembled inside the drum and we set the drum down inside the trans, we're not going to see the problem very easily. What the complaint will be is your first road test after rebuild, you kind of felt a 2-3 drag or bind. Then all of a sudden there's no 2-3 shift at all. Then we're going to be into fail-safe. What you're going to do is you're going to drop the pan. You're going to find a lot of fine aluminum material in the pan. And that's because the difference between the two clutches is on these smaller engines like the 6 cylinders versus the 8. The outside diameter of these two clutches are the same. It's the inside that's different. And here's the two clutches, one laying on top of the other. You can see the outside diameter is the same. And there's a tremendous difference on the inside diameter where the actual teeth of the clutch are going to set down on top of the planetary. So that's correct. There's going to be two different planetaries for this unit, smaller engines versus the V8. So if you take the clutch and you set it down, the large clutch down onto this planetary, that's where your problem is, and you're not going to feel that during assembly. It's going to go together pretty easily. Obviously we can't make the mistake in the other direction because we're not going to fit the smaller clutch on the larger planet. So you'll pick that problem up real quick. Here's what happens when we take the V8 and we put it on the smaller planet. You can see the teeth here are barely catching the splines on the hub side of the planetary. And like I said, you probably get 1, maybe 2 shifts out of it before the failure happens, and you'll see all that metallic dust in the bottom of the pan. This is how it should fit if it's the correct clutch for the correct planet. I advise taking the clutches from the kit and checking them on the splines on every rebuild to make sure that your kit wasn't misassembled with the wrong clutches. You have all the clutch diameter, tooth counts, thicknesses, and part numbers there for you, including the quantity of clutches per drum. So you have all that information in your handout. No upshifts. This is real common on Mercedes especially. Same thing will happen on a Chrysler product. If the ABS light is on any Mercedes vehicle, that transmission is not going to upshift. It's not going to upshift, and there will be no transmission codes. So if you have ABS issues or wheel speed sensor codes, you're going to have to correct those first. Now, on some Mercedes, you'll find a single output speed sensor mounted on the rear axle, but there are other models that will have one front wheel speed sensor that's going to control or tell the computer vehicle speed, so that the computer will command the upshifts. So be aware that any ABS lights will cause that problem. Here's a complaint of a harsh 3-2 downshift, and that's because of the pressure feed valve. The spring was weak or broken, and the valve wasn't actually touching the plate. So like I said before, the top of this check valve has to have some pressure up against the plate. Early shifts, late shift, harsh shift complaints, even soft shifts. All these complaints, not on just this vehicle, but just about everything that we work on out there today, Fords, GMs, it doesn't matter. Mass airflow is probably the #1 sensor, not only for shift timing, but it's the sensor for load, for engine load, and that's also going to control pressure rise. So any kind of shift complaints and things like that, especially if you have a mass airflow sensor code, we're going to have to go there first. Now, one of the things we want to do is take a look at the wiring, make sure there's no areas where it rubbed through, where the wiring may be shorted, because you can actually have a mass airflow sensor that's not setting a code, working improperly, that it's not controlling the line pressure correctly, and have shift flares or harsh shifts. One of the things that I like to do when these vehicles come in is I'll take the air filter out and look at it. If it looks like it's the type of a customer that doesn't maintain their vehicle, if that air filter looks pretty dirty, I can pretty much guarantee you that the mass airflow is dirty. It's always a good test to go ahead and clean it, but don't use brake clean or carburetor cleaner. There are spray cleaners that are made just for mass airflow sensors. Using those sprays will prevent any issues with causing O2 sensor damage, so you should use the correct spray to actually clean those. Now, you may actually go in there and clean it 1 or 2 times before you'll actually see a difference in the way it shifts. But it's something that should be done on any vehicle that's giving you that type of a problem. No move condition, no upshifts. This is a good time to take your scan tool out, even if you don't have these codes. The U0404 is probably the most common code I see on Jeeps. It's for the shift module that's part of the shifter. So the module is actually down inside the shifter here. If you have any issues with that, it can actually have a no move condition. I've seen times where there's no codes for it, but if you do have that code, and I can almost guarantee you if you call your Jeep dealer, they'll have that in stock. They'll have the whole shifter assembly. I've had guys tell me, I know at one point we could buy just the module and change it, but from what I'm being told now, they're actually selling the whole shifter assembly. They're not selling the module separate. But that depends on, I guess, on the dealer you're dealing with. I don't know what it's like across the whole country. I do know that in some areas, that's what I'm being told. Now, this is also a great area for coffee and soda to be spilled in here. A lot of guys that change just the module would find later that the rivets or the brackets that hold the shifter assembly over time were just coming loose, and that was actually what was causing the problem. So I ended up having to change the whole shifter assembly anyways. So be aware of that, especially look for any kind of stains from coffee or soda. This is a pretty common complaint on these vehicles, a ringing sound coming from the drive shaft. You can kind of hear the noise when you put the transmission from drive to reverse or from reverse to drive. This is mostly found on Chrysler vehicles. As you can see here, we have 4 different part numbers for the output flange, obviously for 4 different engine sizes. So you have that information there, and then we also give you the tool numbers for the OE tool, but obviously you don't have to use the OE part number. You can use whatever tool you need to do this job here of taking the flange off. So we have the information there in the book for you. This is something we're seeing quite often. So if you have that complaint, this is the first thing that we're going to have to do to change this and update it. PO730, it's my most dreaded code. I hate this code on the tech line. Basically what the computer is saying is something is slipping. It doesn't tell us what gear is slipping. We may actually drive the vehicle, and by the seat of our pants it thinks the transmission seems to be shifting fine. It doesn't have a slip, but we end up with a PO730. Now, on Chrysler vehicles, there is an actual TCM recalibration. It kind of widens that window, or narrows that window, I should say, so that the amount of slip that the computer is picking up doesn't set the code. One of the other things I'd like to mention is this is the OE scan tool, the DRB3. It's actually available now to the aftermarket. I don't know what they're selling it for. Again, that may depend on where you're buying it, but just to let you know that you can actually get the factory hand tool now for the Chrysler products. Same thing here as you see on the right. This is the YTech. This is the software that does everything that the handheld tool does, but this can be loaded onto a laptop. So you could have one laptop, put all kinds of different scan tool software on it. So now you've got one tool that can do several different type of vehicles. In today's market, most of the OE have gone to laptop software. They're not using handheld scan tools at the dealer level anymore. So that's where the future is going, so it's something to think about. Stuck in failsafe, unable to clear codes, or you may even have a transmission that's in a failsafe, but there are no codes for the transmission. You'll go and check the TCM to find out that it's sending no voltage to the solenoids. Modules have been changed, TCM modules have been changed, nothing seems to fix it. If you look in the other modules, you'll find you may have some transfer case codes there. If there's anything going on with communication between the transfer case module and the TCM, or if you have a transfer case shift motor that's not working correctly and that's setting codes, anything going on with that transfer case will put the transmission in failsafe, and the transmission won't shift. You'll be stuck in failsafe only because you have a problem either with the transfer case control module, or any issues with communication back and forth, or any problems with the transfer case shift motor. So keep in mind that if you're working on some four-wheel drives, one of the things that I like to suggest is we always put the year, make, and model of the vehicle in our scan tools. If you don't see all the codes or see codes in other modules that way, back out and go back in with the scan tool, except this time go use the generic mode. Because in the generic mode, if there's any code stored in other modules, they will definitely come up in the generic mode more often than you would see if you put it in under that particular vehicle model. Ratio codes and failsafe. I've had several Chryslers and Jeeps where two-wheel drives, there was an issue with the differential. Somebody swapped the differential out and put the wrong differential in. So you can actually end up with ratio codes like PO731, 732, and it's because somebody actually changed the differential on the vehicle. I've seen it on Chrysler cars, and I've also seen it on Jeep vehicles. Not too long ago, I did a tech call on one. The transmission came in, it was in a Jeep. They had a problem with the sun gear. The front sun gear was bad, so they had to change all that. I went back and talked to them and found that we had the right ratio in it, but it kept setting codes. So as a test, I said, go to the battery, disconnect the battery cables, clean them up. Even if your battery looks as good as the one in this picture, that's just a joke, guys. If your battery looks that bad, obviously you're going to need to go there first. But even if the battery terminals look new, clean them, follow the ground down to where it goes, clean that ground up. Now these guys dealt with this Jeep for like a week and a half. Just by doing that on this Jeep, we've actually fixed ratio codes on it. Now in my shop, that tool that you see right there to clean the terminals, every one of my installers had that. Every vehicle that left my shop always had the battery cables cleaned and the ground strap cleaned also. So they would follow that ground cable down to where it went, unbolted it, cleaned it up, and put it back. That's real important on just about any vehicle with electronics in today's market. Well, that ends our presentation for today. I'd like to thank you all for attending. And I also want to thank Seal Aftermarket Products for sponsoring our seminar and making it available to anyone. Now, if you have any questions before I close out the webinar, I would like you to look on your list where your name is, and you'll see a little hand sign. If you have a question and you're going to take time to type it in, go ahead and put up your hand so I can see that there is a question coming in. This way here I won't click out of the seminar too soon. Okay, it looks like we're not going to have too many questions coming in. Just a reminder, in 2 weeks from today at the same time, the next webinar will be on the LCT 1000. So I hope to see you guys attend that one. Okay, that looks like that's about it for questions. I want to thank you guys again, and I hope I see you in 2 weeks for the LCT 1000 webinar.